Main focus is on serial communication between the ATtiny and the computer, and in this case we'll be using the Arduino Uno as the interface. The wiring diagram is as shown on the screen. As you know, the pin 5 is the MOSI pin, then the pin 6 is the MISO pin, pin 7 is the clock pin, and then pin 8 is VCC. On the other side, pin 1 is the reset pin, pin 2 and pin 3 are the input-output pins 3 and 4, and pin 4 is the ground. So you're going to wire it this way, and there's a reason for this wiring. You wire it this way, and then there is a capacitor from the reset pin of the Arduino Uno and ground. So you want to have that set up that way. Alright, so here is the setup. We've already wired this up here. That's the Arduino Uno. That is the capacitor to ground from the reset of the Arduino. And there is the ATtiny, and then all the wirings in place. We have an LED to just show the ATtiny flashing a diode. What we want to show is a serial communication from the ATtiny and the computer. So right here on the left side, you have the Arduino as ISP code. You want to flash this first to your Arduino Uno. Now, to find this code, you go to File, Example, and then you go down to Arduino ISP and you open that Arduino ISP. When you open this code, you will notice the pins, your MOSI, your MISO, and your clock pins 11, 12, and 13. That is why we had to wire this as so. So this is 11 for the MOSI is 11, MISO is 12, and then the clock is 13. So you have to wire it as such. Once you complete the wiring, you have to flash this. First of all, drop down the menu, the tool, and make sure that it is the right board selected, Arduino Uno. Once that is selected, you go ahead and click on Upload. Now, ensure to remove the reset pin from the capacitor, as well as the transmit and receive wires from the ATtiny. Once this is done, you go ahead and flash. So click on Upload. Sometimes you might have to click it twice, and if there's a conflict with your serial monitor, you might want to unplug it from the computer and plug it back. But now the upload is done. Once this is done, the next thing is to flash your code, which is the next code here. We've written a very simple code, and this code simply blinks an LED on and off. So we set it at 100 milliseconds and the baud rate at 9600. So for that, plug back the reset. That's the only thing you need to plug back. Leave out the transmit and receive wires for now, and then click on Tools and change the board to ATtiny. Take the right version for you. In this case, we're using 85. Select 85, and then go back and click on Sketch, Upload using Programmer. Again, if there's a conflict with your serial monitor, you have to unplug the USB cable and plug it back. But it does seem that everything is going smoothly now, and it's done uploading. Once this is done, you have to go back and remove the reset wire one more time. You can put it somewhere where it is not interfering with anything. You remove that, and then you want to flash another program to your Arduino. This is called bare minimum. It's just empty code. So to get this bare minimum, you go on File, Examples, Basic, and then bare minimum. We have it already opened here. So you go ahead and make sure that you select the right board, which is your Arduino Uno in our case. and then flash the code by clicking on this upload. It should take a few seconds and the sketch will be uploaded. Right, the upload is done. Now, to monitor or to observe the signal on the serial monitor, we have to plug in the transmit and receive wires. So we go back here and connect our wires to the transmit to transmit, and receive to receive. Now, once you plug in the transmit and receive wires, you can see the LEDs blinking. Now you just go back to the serial monitor. And you can see there's gibberish being printed. And this is so because for some reason there's an issue with the baud rate. Anytime you see this backwards question mark, there could be a potential issue with the baud rate. So what we're going to do is to change this baud rate. Experimentally, we found out that 1200 works well here. So we're going to select 1200, and then all of a sudden it starts working properly. So when the LED is on, you get LED on. When it's off, you get LED off. Alright. So to recap, what we've been able to show today is how to flash the ATtiny using the Arduino Uno. We've also shown how to get serial readout from the ATtiny. Now you don't need these other wires. You can take them all out, and we're going to do that now. We don't need the rest of the wires. All we need is the transmit and receive wires. Actually, we just need the transmit wire. We can remove the rest of the wires. Alright, so let's do that now. So we're going to take the reset out. It was already hanging, doing nothing for us. We're going to remove the MOSI and the MISO and the clock. They weren't doing anything anyways. We can actually remove the transmit and receive wire and just replace the transmit only. So let's use this wire to replace the transmit. As you can see, there is no let me just clear the serial monitor. There's no signal right there. But now I'm going to connect one wire to the transmit and then also to the transmit of the Uno, and you can see it displays there. So all you need is the power supply, and then I don't need this reset either, so I'm going to take it off. We don't need that. So basically what we need is the power supply, which is these two wires, and then this from the transmit. Now don't be deceived, the transmit is working because there's a ground, a common ground between both of them. So you need two wires. One is the ground and one is the transmit, and then we have the power supply also. So basically what you have is here, all the wires are out. We don't need those wires anymore for this. Now whatever code you have programmed on your ATtiny, the function or the response you can monitor. This is for debugging purposes only. If you're writing a code for this ATtiny, you can use this setup. Again, you don't have to use the receive pin really. If you don't want to send instructions to the ATtiny, you can just declare the transmit pin only, then use that to send the debug instructions to your serial monitor so you can see what is going on in your code. So let's change this to blue light. We just have to flip this over. All right.